Hi, my name is D. Sri Chandra Reddy of Data Science C section. So my TED topic of probability and statistics is discrete random variables. So let's dive into the topic. So the random variables. A random variables is a numeric measure of the outcome of a probability experiment. Random variables reflect measurements that can change as the experiment is repeated. Random variables are denoted with capital letters, typically using X and Y and Z. Values are usually written with lowercase letters, typically using X and Y and Z. Next, the random variables are two types: discrete random variables and continuous random variables. So my topic is about discrete random variables. So first I will say about discrete random variables. Before that, I will go a small bit of the topic continuous random variables. A bit similar to the discrete random variables, but it is finite length. It used in the finite uh, objects, but in continuous discrete random variable, you use uh, infinite random variables, infinite variables. Like so, a discrete random variable is a random variable that has either a finite or countable number of values. Before I said it has a finite number of or countable of values. So in continuous random variables, it has infinite and uncountable number of values. So we use an integrated part in that continuous random variable. A finite number of values such as 0, 1, 2, 3, and 4, and a countable number of values such that 1, 2, 3, like so on. Discrete variables are designed to model discrete variables. Discrete variables are often counts of. Example of random variables: tossing 4 coins or counting the number of heads. The number could be 0, 1, 2, 3, or 4. The number could change when we toss another 4 coins. Measuring the heights of students. So the heights of students is also the example of random variables. The heights could change from students to student. Next, example for discrete random variable. The number of heads in tossing 3 coins, a finite number of possible values. In random variables, it is an example we can say tossing of a coin means how many we can throw a coins. If it's countable, yes, it is discrete. If it is uncountable coins we can throw, it is the continuous random variable. So next, a finite number of possible values of tossing 3 coins is an example of discrete random variable. So there are 4 possible values: 0 8, 1 8, 2 8, or 3 8. So a finite number of possible values is called a discrete random variable. So this is the perfect example for the discrete random variable. So this fits our general concept that discrete random variable consists are often counts of discrete random variables. Other examples of discrete random variables are the possible rows when a rolling pair of die. So it is also can be called when we call a pair of dice is rolled. A finite number of possible pairs are ranging from 1, 1 to 6, 6. So the finite number of outcomes we got from the dice is a discrete variable, is countable, which are countable, and continuous, which are infinite. So the number of pages in statistics textbook are countable. So the number of pages in the statistics textbooks is also an example of discrete random variable. A countable number of possible values. The number of visitors to the White House in a day. So it is also an example of discrete random variable. Countable possible values. Next, probability distribution. The probability distribution of a discrete random variable x relates the values of x with their corresponding probabilities. A distribution could be in the form of table, graph, and the mathematical formula. The discrete random variable of the probability distribution we can be it in form of graph or table, or it can be mathematical formula. So if x is a discrete random variable and x is a possible value of x, then we write p of x as the probability that x is equal to x. So p of x is equal to x is an we can denote as the probability of discrete random variable. Examples, in tossing one coin, if x is the number of heads, then p of 0 is 0.5 and p of 1 is 0.5. Next, if rolling one die, if x is the number rolled, p of 1 is 1 by 6. So the tossing one coin and the x is the number of heads, p of 0 is 0.5 and 0.5 is the perfect example for probability discrete distribution function. So in rolling one die, if x is the number rolled, p of 1 is the 1 by 6. It is also the perfect example for probability distribution discrete variable. Probability distribution properties of p of x. Since p of x form a probability distribution, thus must be the rules of the probability. The probability should be rise between 0 to 1 and sum of the probabilities is equal to 1. These are the main rules should have be in discrete random variables. So in the second rule, the sigma means to add up the p of x of all the possible of x. So the sum of all the possible of x is equal to 1. So probability distribution. An example of discrete random probability distribution: x 1 2 5 6, p of x 2 6 1. All the px values are positive. They are add up to 1. Not a probability distribution. An example that is not a probability distribution: if px1, p of x2, 2 6 5 minus 3 and 6 1. Two things are wrong. P of 5 is negative and p does not add up to 1. It's by the rules of the discrete probability distribution, it should be 0 up to 0 to 1, and it should be positive, and p of all added to it should be equal to 1. The summation of all the p of x is equal to 1, but in this case it is not add up to equal to 1. So these two things are wrong. So this is not a probability distribution. So next, mean of probability distribution. The mean of a probability distribution can be through if of is this way. There are various possible values of a discrete random variable. The values of the higher. There are various possible values of discrete random variables. The values that have higher probabilities are the ones that occur more often. The values that occur more often should have a larger role in calculating the mean. The mean is the weighted average of the values weighted by the probabilities. Mean of discrete random variable. The mean of a discrete random variable is mu x is equal to sigma of x into of px. So this is the formula of mean of discrete random variable. So x are the possible values of x. P of x is the probability that x occurs. Sigma means to add up all these terms of all the possible values of x. So in mean, example of calculation for the mean. Suppose x is 1 2 3, 1 2 5 6 and p of x is 2 6 1 1. So by 0.2 0.6 0.1 0.1. So add 0.2 plus 1. 0.2 into 1 plus 1.6, 0.6 into 2 plus 0.1 into 5 plus 0.1 into 6. It can be added to 2.5. This means the discrete random variables, the mean of the discrete random variable is 2.5. But sum of all this using formula, we get the mean or the discrete random variable. So expected value. The expected value of a random variable is another term for its mean. The term expected value illustrates the long-term nature of the experiments. As we perform more and more experiments, the mean of the results of those experiments get closer to the expected values of the random variable. Next, it comes to the variance. The variance of a discrete random variable is computed similarly as for the mean. So it is same as the mean, but variance and standard deviation is also bit almost similar. It's equal. Variance is sigma square, and standard deviation is root of sigma square. This means the is the weighted of the sum of the values mu of x. So the main formula of the discrete random variable is mu of x is equal to sigma of x into p of x. So the variance is the weighted sum of the square difference from the mean. So sigma x square is equal to x minus mu of x whole square into p of x. So as I said, the standard deviation, as we seen before, it is the square root of the variance. So sigma x is equal to root of sigma x square. So sigma x square is equal to summation of x minus mu x of whole square into p of x. So the variance formula is sigma x square equal to summation of x minus mu of x whole square into p of x. Can involve calculations with many decimals or fractions. An equivalent formula is sigma x square is equal to, so we can write the another formula like sigma x square equal to sigma summation of x square into p of x minus mu square. So this formula is easier to calculate the variance. So the variance can be calculated by hand, but the calculation is very tedious. So the variance can be calculated by hand, but the calculation is very tedious. So the variance can be easily calculated, but the calculation by hand is very hard. It takes longer time. By using calci, it will be very simple. I can find variance easily. Whenever possible, use technology like calculators, software programs, etc. to calculate variance and standard deviations. So as I said, by using and we can get more big values, and it is very difficult to calculate by hand. By using calculators and software programs, you can calculate easily of standard deviation and variance. The summary we have learnt about the discrete random variables are the measures of outcomes that have discrete values. So as I said at the start, discrete random variables and continuous random variables. So the continuous random variables are infinite length. So it is similar but to discrete random, but is infinite. Same as we calculated in mean and standard deviation and variance, we calculate in discrete. We also calculated. We'll also calculate in continuous random variable also. There also will be mean, standard deviation and variance, but it has an integral part of probability distribution. So discrete random variables are measures of outcomes that have discrete values. Discrete random variables are specified by their probability distributions. The mean of a discrete random variable can be interpreted as long-term average of repeated independent experiment. The variance of discrete random variable measures is dispersion from its mean. So thank you. This is my PPT presentation of discrete random variables. Thank you.